Good afternoon, ladies and gentlemen. It's my honor to be here today to talk about my project, the research on Kaprekar's constant 6174. I'm Taoyu from number 2 High School of East China Normal School, Shanghai, China. Firstly, let me introduce a problem I've solved for any n-digit number by using its positive sequence number to minus its inverse ordinal number. It will get into one cycle, or it will repeat itself. Here are an example of the application. The existing findings include the cycles of certain digits, the proof of the existence of cycles, and some important properties of self-cycled numbers. And here are my main findings. I divide the number field according to one-Martin numbers and p-Martin numbers. I calculate the range of numbers where we can find the main cycles. I link Martin numbers with one-way function, which can be applied in cryptography, which is really important. Then I will tell you my definitions. I define p cycles as cycles related to Martin numbers, p-Martin numbers as Martin numbers which have the cycle structure and p is more than 1. One-Martin numbers as Martin numbers where p equals 1. And cycles with cycle numbers greater than 3 are main cycles, otherwise it is a paracycle. Also, I got a one-way function. For each input, this function value is easy to calculate, but giving a random input function value, it is really difficult to calculate the original input. Also, I define the t, d, w, and x, and the definitions are referred to the PPT. Also, I define the kn. I define epsilon as transition numbers, which are Martin numbers, which is both in w and x. And which is really important, I got the word function. The places where most main cycles exist, I draw an overline. The places where most paracycles exist, I draw an underline. And here are my main findings. The first one is a kn. Also, any number in the cycle is divisible by 9. To any random n-digit number, it is limited or it will result in the cycle n. What's more, I got the epsilon ni. Its range is really important in cryptography. Also, when the n is big enough, the probability of the paracycle appearing in all the cycles is nearly 1 in 2. The transition number occurs only when delta half of the n equals 0, or half of the b as 1 under b basis. Its main applications are in cryptography. For any n-digit number, by using p-Martin numbers and one-Martin numbers, we can divide them according to its range, which has been achieved beforehand. Then, we can get a self-cycle number and set a one-side function, which can get the existing probabilities is less than 1%. And in the theory, we can find its range in its central part, and then we can look for the passport easily. In future work, I will mainly focus on extending these conclusions to different base systems and limiting the range of the cycles to a smaller one, which can make the calculation easier. And finally, thanks for watching. Thank you.